Hi, welcome to the channel Coder's Arc, where we unravel the world of coding and architecture together. And the topic of today's conversation is simplest Lambda tutorial, step-by-step SQS triggered Lambda. Here are the steps. First, we will install the AWS Toolkit for Visual Studio. We will connect the AWS account to Visual Studio using the IAM Identity Center or secret and access keys. Create a Lambda function from out-of-the-box SQS Lambda template provided by Visual Studio. Publish code to AWS Lambda. Assign appropriate IAM privileges for Lambda function, which include the SQS access, CloudWatch access, and Lambda access. Send the test payload to queue. See contents in the CloudWatch logs when the Lambda is triggered. And finally, we will set up the dead letter queue. I also want to illustrate this through a diagram, which will help clarify how the SQS works. We have a source application, which is the producer, which would create a payload, and then it will send it over to the queue. In our example, we'll use the SQS screens for sending the payloads. We will also set up a dead letter queue, and dead letter queue is useful when the queue is unable to process a message due to many reasons. It could be because of an internal exception, some other errors happening on the consumer side. So we will send the messages after a certain number of retries back to the dead letter queue. And on the other side of the consumer, which is the Lambda function here, it can have many destinations. We will not be covering the code for the destinations here, but as you can see, the consumer function can either store the contents in the relational database, in the object storage, or send it further to another queuing services. And these are just some destinations. We can have multiple more destinations like SNS, other dynamic databases, etc. So let's dive right into the code. So now I am on the Visual Studio 2022 homepage. From here, we will click Create a New Project. Again, you can see the list of recently used project templates as well as all the templates that are provided by AWS in various languages. As you can see, there is C#, F#, JavaScript, Python, TypeScript. So let's select the AWS Lambda project .NET Core C#. Click Next. Give it a meaningful name. Click Next. From here, we can see the list of available blueprints from AWS library. As we can see, there is options for S3, Kinesis, DynamoDB, SNS, but we will choose the SQS. Click Finish. And as you can see, the code is automatically generated. Let's take a quick look at the function. Again, there is an important method which is called the function handler method, which is triggered for the Lambda whenever the message is put on the queue. This method gets called automatically. And then you also have a Lambda context object passed over here. In our code, we won't be making much changes. We'll use the code as it is automatically generated by Visual Studio. But let's take a look at it. Here we are just printing out the process message payload body. So let's push this method to the AWS Lambda. Click on Publish AWS Lambda. And from here, you can see the AWS credentials profile that you might have already preset. And then we will leave all the default settings. Let's give it a meaningful name. And this is the function name that is displayed when the method is shown on the AWS Lambda screen. And here you can see something which is extremely important is the function handler, where you specify the assembly name, then you specify the namespace, and the name of the method that you're using. It is extremely important that the name of the method that you choose in the code matches the same name that you have over here. Click Next. So now we have to choose a role that the Lambda function will acquire while running this Lambda. So from here, we can see there are some existing roles. I will choose a role based on AWS managed policy, and I will give AWS Lambda full access. In production, you can granularly assign the permissions, but for now, just to illustrate this demo, I will use AWS Lambda full access. And I will leave all the other settings as default, and I will click upload. We will give it a few minutes. As you can see, what happens in the background is that it zips up the code, assigns the role to the Lambda, and pushes this code as a package onto AWS Lambda using the CDK. All right, so it looks like our Lambda function is successfully deployed. Now we will be logging into AWS console and seeing the Lambda and setting up the testing of this. Okay, so now we are on the AWS homepage. From here, let's go to the Lambda. And here you can see that the Lambda function is successfully deployed. Let's click into it. There are various tabs for code, test, monitor, configuration, aliases, and versions. They all have very important meanings. But for now, let's look into the permissions. This is, if you remember, this is the role name that was automatically created. And if you click into this role, you will see that it has the Lambda full access, which is what we assigned at the Visual Studio. So now let's add a couple of more important policies. So the first policy that we will add is the SQS full access. Again, this is for the purpose of this demo. When you're setting this thing up in production, you will not be giving full access. You will be assigning appropriate access to the resource that your Lambda is supposed to access. And also you will be giving permissions like read, write, and other granular permissions based on the rules of the function. But for now, we will just use the AWS full access. Add the permission. Another policy we need to apply is the CloudWatch log policy, just so that we can view the logs. So we'll search for CloudWatch logs and again give it full access. So now with these three permissions, we should be able to test the Lambda. So before we can start testing the Lambda, let's create a couple of queues. One would be the primary queue and the other would be a dead letter queue. So we'll choose a standard queue and we'll call it coders arc SQS Lambda trigger. And we will choose all the default settings. There is a lot of important details on these configuration settings, but we will skip them for now and hit create queue. And we will do another queue creation, which is the dead letter queue. So let's call it the same thing, but we'll prefix it with DL. And we'll leave the same default settings and click create. So now we will go back to the primary queue and go to the tab dead letter queue. And from here, we will click edit. We will enable the dead letter queue, which was an optional. And from here, we will choose the dead letter queue. And what this means is that anytime there is an error on the primary queue, we will be sending the message over to the dead letter queue after a certain number of retries. And one other thing is this value maximum receives, which is 10. Let's edit it to a simpler value. Let's make it 3. So that after third attempt, if a message fails to process on the queue, it will go to the dead letter queue. So let's click save. And that's our queue setup. So now let's go back to the Lambda. And here we will click add trigger. We will select the source as we've seen before, it can have many sources, but for the purpose of this demo, we will choose SQS and we'll select the queue on. So we will select the primary queue. What that means is if there is a message that lands on the SQS, this primary queue, the Lambda, which is constantly polling the SQS queue, will pick that message and process that message. So we leave all the default settings. All these settings have very important meanings when you are in a production scenario, but for the purpose of this demo, I'm going to skip all of this and click add. So now our setup is complete. And now let's see if we can test this. Okay, so now we will go back to the same queue, the primary queue. And from here, we will click send and receive messages. And let's enter a very, very simple JSON payload. So once you've constructed the payload, you will leave all the default settings. And now you can click send. So let's look at the Lambda. Go to the monitor tab. And now we want to look at the CloudWatch logs. Click on the CloudWatch logs. And here you can see the log stream. Let's click on the log stream. And the message that I just sent is showing over here. So we were able to successfully illustrate how a message is sent from the queue to the Lambda. But now we want to test the scenario of dead letter queue. So let me go back to the code. And let's purposely introduce a coding error. So let's purposely introduce an exception that will cause the message to fail. So I will paste some code that will throw an index out of bound exception. So it's a very simple code. You have an array of 5 numbers, but I'm trying to access the 6th number, which means it will throw an index out of bound exception. So let's save this and publish this to AWS Lambda. Click upload. We will use the same settings, so we will not change the settings. Click upload. And let's go back to AWS screen. Go back to Lambda. The last modified was 17 minutes ago, so let's refresh it. So okay, so now the new version of the Lambda is available. So let's test the message again. Go back to the SQS test, and from the send and receive messages, let's send that payload again, and let's observe what happens in the CloudWatch logs. So let's look at the logs here. So as you can see, it throws an index out of bound exception as expected, but it will retry 3 times because if you remember, we set the retry count to 3 when we were setting up the dead letter queue. So let's see. And while this is happening, let's go and look at the queues. And see, there is one message in flight for the primary queue right now, and that'll stay. So let's go back to the CloudWatch. Okay, so it threw exception the second time because Lambda will keep trying. And give it a few more seconds. Okay, so it's tried 3 times. So let's go back to the queues. On the 4th time, it will land on the dead letter queue. So as you can see, the message is still in flight on the primary queue. Let's refresh it a few times because on the 4th attempt, it should land on the dead letter queue. Okay, so as expected, the message is now on the dead letter queue, which means based on the configuration of dead letter queue, it will stay here. By default, I think the message stays there for 4 days. This is a very good way to set up some alerts in the production scenarios where if the messages land up on the dead letter queues, you can take some actions, maybe some DevOps actions, some developer actions, some infrastructure actions. But the whole intention is to figure out why the method failed to process the message, and then figure out that and take this message that is on the Delaware queue and resubmit it to the Lambda once the issue is fixed. So that's it. So from this tutorial, we were able to see how primary queues work and how the message is triggered, or how the Lambda is triggered when the message is placed on the queue. We were also able to see how Delaware queue works with the primary queue, and if a primary queue is unable to process messages, then Delaware queue automatically receives those messages after a certain number of retries. This is very useful for building robust serverless solutions in the cloud. So I hope you found the information in this video useful. If you did, please hit the subscribe button and the like button, and feel free to ask me any more topics that you want me to make videos on. Thanks a lot.